A company is considering evaluating a project which requires investments. Now again, there are multiple investments, unlike in normal questions in which there is only one investment. Project requires investment of 5,000 now and 2,000 at the end of year 1. So it actually requires 5,000 rupees now, and it also requires 2,000 at year 1. The cash inflows from the project will be 7,000 at the end of year 2 and 6,000 at the end of year 3. The discount rate is 16%. Complete the following table. Use table to calculate the present values. So I have put in all the cash flows over here. Now I have to put the discount rates. The first discount rate would be, or all discount rates will be calculated as 1 divided by 1 plus I power n. First discount rate would be 1 divided by 1 plus 16% power 1. If you compute the first discount rate by a calculator, it will be 0.862. 0.862. And if you compute the second discount rate with 1 plus 16% power 2, it will be 1 divided by 1.16 power 2, which is 0.743. Third discount rate will be 1 divided by 1 plus 16% power 3, 1 divided by 1.16 power 3, and it is 0.641, and this is always 1. Now if I multiply 5,000 negative by 1, it will be negative 5,000. Negative 2,000 multiplied by 0.862, 1724. 7,000 multiplied by 0.743, 5201. 6,000 multiplied by 0.641, 3846. Netting everything off, 3846 plus 5201 minus 1724 minus 5000, 2323. Second question. A company is considering a project which will cost $26,000 now and would yield 4,200 rupees per annum in perpetuity. Perpetuity means P is equals to R divided by I. Starting 1 year from now, the cost of capital is 12%. Present value of perpetuity. Present value of perpetuity is R, or 4,200 divided by I, 12%. 4,200 divided by 0.12 will give you 35,000. Net present value of project. Net present value is present value of inflows minus present value of outflows. Present value of inflows is our perpetuity, which is 35,000, minus present value of outflows. Outflows is 26,000. So net present value is 9,000. Third question is a bit different. It says an investment will generate cash flows of 3,100 each year in years 3 to 7. That is first amount to be received 3 years from now. The discount rate is 15%. The present value of the cash flows, using table to calculate your answer to the nearest dollars. Now if we do not use our table, we can still calculate our answer. By table, it refers to the annuity discounting table. First, let us have a timeline for this. Year 0, year 1, year 2, year 3, year 4, year 5, and so on till year number 7. An investment will generate cash flows of 3,100 each year in years 3 to 7. 3,100, 3,100, 3,100 and 3,100, so on till year 7. The discount rate is 15%. The present value of the cash flows. You actually have to bring all of these cash flows to year number 0. There are 3 methods to do this. I will solve this by 2 methods and explain one method verbally. The first method is to method number 1 is to first apply the present value of annuity or ordinary annuity formula. What will this formula do? This formula will bring all these cash flows to present value terms, and remember that present value of ordinary annuity formula brings these values 1 year back. So they will bring all values over here. But since you have to calculate year 0 values, you will then discount it normally for 2 years. So in under first method, your first step will be to use present value of annuity, ordinary annuity, and then simple discounting. Let us solve this by first method. We know that P or present value of ordinary annuity is R into 1 minus 1 plus I power minus n upon I. Now we know that P is equals to 3100 multiplied by 1 minus 1 plus discount rate is 15% power minus how much? The number of payments 1, 2, 3, 4 and 5. We have 5 payments, year 3, year 4, year 5, year 6 and year 7. Power minus 5 divided by 15%. If you compute this value, it will be 1.15 power minus 5, 1 minus answer divided by 0.15 multiplied by 3100, which is 10,391. 10,391. Now remember, this value is at this spot. We have to calculate the present value or bring it 2 years back further. So we will do simple discounting using S is equals to P 1 plus I power n, in which S of future value is 10391. P or present value needs to be calculated 1 plus 15% power 2. P will be 1.15 power 2 10391 divided by answer, which is 7857. 7857 is our answer. This is method number 1. Under method number 2, what you can do is simply bring this 3100 rupees 3 years back, bring this 3100 rupees 4 years back, bring this 3100 rupees 5 years back, bring this 3100 rupees 6 years back, bring this 3100 rupees 7 years back by simple discounting, and then add all of the values which you have calculated. This will be method number 2, which I am explaining verbally. Now under method number 3. Method number 3 is a bit new. Let me draft the question again. Here 0, 1, 2, 3, 4, 5, 6, 7. Method number 3 says that to discount all cash flows of 3100 rupees in these 1, 2, 3, 4, 5 years, what you can do is firstly calculate the discount factor for all these years. Now what is discount factor or NVT factor? P is equals to R multiplied by 1 minus 1 plus I power minus n upon I. This portion is called NVT factor or discount factor for NVT. Method says that firstly compute the 1 to 7 discount factor. By 1 to 7 discount factor, we mean 1 minus 1 plus 15% power minus 7 divided by 15%. And if you calculate this will be 1.15 power minus 7, 1 minus answer divided by 0.15. This will come out to be 4.160. Interestingly, you must also know how to use the annuity table, and this amount or this figure is easily available and visibly available in your annuity factor table. Then method says that since you did not have cash flows in first 2 years, subtract the discount factor for these 2 years. What will be the discount factor for these 2 years? It is easily available on your annuity table, or you can compute it by 1 minus 1 plus 15% power minus 2 upon 15%. If you compute this 1.15 power minus 2, 1 minus answer divided by 0.15, it will come out to be 1.15 power minus 2. 1.626. 1.626. If you net both of them off, it will be 2.534, which will be the discount factor for 3 to 7. Since this had discount factors from year 1 to year 7, you subtracted discount factor from year 2 to year 1 to 2, and you are left with discount factor for 3 to 7 for this time period. Now under this method you can simply use the 2.534 and multiply it by 3100 to get your desired answer, which will be 2.534 into 3100, which is 7855. If you check, this answer matches with 7857. 2 rupees is due to rounding off. Thank you. For more MCQs, please stay tuned.